Hi guys, we're going to be applying those nifty tangent lines to circles in the coordinate plane. Okay, so we have circles that are externally tangent and internally tangent. Remember, these are externally tangent because they touch on the outside of the circle. These are internally tangent because they are touching within the circles. It's circles within circles that touch at a point. Guys, so our circles are tangent as well as we have a tangent line. So there's lots of tangent things going on. Guys, and I recommend you do this on graph paper because if you see, my coordinate grid was not perfect and it made me draw this really rough circle, but it's okay. I like my circle, but if you want your circle to be a little bit prettier than that, I recommend doing it on a piece of graph paper. Also, guys, I apologize. I squeezed in the directions at the top. I forgot to put the directions and I put them in late, so that's why they're kind of squeezed in at the top. So I apologize. But anyway, so between our two circles, we're going to be finding the length of each radius, identifying the point of tangency, and then we're going to write the equation of the tangent lines. We're going to do that in both of our circles. So I'm going to start on this one. All right, so the radius length we're simply going to get by counting the distance from the center of each circle to an endpoint, which probably the easiest, it really doesn't matter which one you do, but it'd be best to either count up from the center, down from the center, left from the center, or right. I'm just going to count up because everything's kind of headed up. The tangent point and the lines are up. All right, so for circle M, let's see the radius. So I'm going to start at the center. Okay, I'm going to count up 1, 2, 3. So this radius right here, if I were to draw a radius right here, the length of that bad boy would be 3. 1, 2, 3. So the radius length for circle M is 3 units. All right, and then for circle N, same thing. If I were to draw on a radius right here, all right, if I count from the center down, bam, that's 1 unit. So for circle N, the radius is simply 1 unit in length. Cool beans, right? All right, so the point of tangency is the point where both of the circles touch as well as this tangent line touches. So where do all these circles and tangent lines come together? What point do you see? Holly hot dog, it would be at the point 2, 1. So that's the point right here. I'm going to bold it a little bit better. So this is the point of tangency, and that's at the point 2, 1. So point of tangency is 2, 1. Oh, you can't see what I'm writing. Sorry, guys. So it's at the point 2, 1. Guys, and then lastly, we're going to write the equation of the tangent line, which since we have a horizontal line, we think horizontal for a y equals horizontal. Think y equals, so horizontal. So this is a y equals equation, guys, and it's y equals wherever this line hits the y-axis. So if we look here, this is my y-axis, this is the x. So this line intersects or smacks the y-axis at the point 1. So it's the equation y equals 1. And if you see, the reason why it's y equals 1 is because no matter what on this line, y is always 1. Y is 1 here. Y is 1 there. Y is 1 there. Y is 1 here. So it's the line where y always equals 1. And guess what, you guys? That problem is donezo. Nice job, you guys.